The next section of the Netlink standard template that we're going to take a closer look at is the mutually exclusive section. Mutually exclusive is a very simple concept to understand. When you flip a coin, assuming you're not using a trick two-headed coin, there are only two possible outcomes, heads or tails, but never can it be both. If we relate this to logic when writing our code, if the coin lands on heads, we'll say that heads is on or true. Therefore, tails is off or false, and vice versa. If tails is on, then heads is off. This section of code is used to ensure that only one item in the group can be on at any given time. You can put variables in here, or even a set of dev-chan pairs. Let's look at a real-world example of using a mutually exclusive set. In the previous tutorial, we built a button event to control a projection screen. When the Screen Up button was pressed on the touch panel, we used a channel manipulation keyword, on, off, pulse, etc., to trigger the relay on our Netlink's controller that's wired to the screen motor. But what would happen if the end user pressed the Screen Up button and then immediately pressed the Screen Down button? Lots of smoke and a destroyed screen motor. The control system would turn on both relays, which would trigger both the up and down on the motor. This is obviously not desirable. The answer? Put both relays inside a mutually exclusive set. Here's what that looks like. First off, the entire set needs to be enclosed inside parentheses. Next, we want to include both relays in the set. We'll start with the first device channel pair, or dev-chan. Anytime you have a dev-chan, it's enclosed in square brackets. So, DV relays is the device, then a comma, and finally, which relay. In this case, we already defined a constant for both the screen up and screen down relays, so I'll put screen up here. Next, we have to include the screen down relay in the mutually exclusive set. I'll start by putting a comma, and then I'll just copy my first dev-chan pair and paste it after the comma. Change the screen up constant to screen down, and that's it. Now we have both relays inside the mutually exclusive set. Therefore, if somewhere in your code you turn on the screen up relay and forget to turn it off, and then you try to turn on the screen down relay, the screen up relay will automatically turn off, thus preventing your screen motor from blowing up. What if you had 3 relays that you wanted to be included in the set? Simple. Add another comma and put in the third relay, like so. Another option, if the relays are consecutive, you can do a range. Put the low range at the beginning of the statement, and then instead of a comma, put in 2 periods. Now, if we look at this, relays 2 through 4 are all included in the mutually exclusive set. Only one of the relays will ever be on at any given time. And finally, you can combine the range with individual items. So in this example, we have relays 2 through 4 and relay 6 all included in the set. As always, after you add some code, compile, and make sure you have 0 errors and 0 warnings. There's one last thing you need to understand when using mutually exclusive. This is very important, so take note. When you turn on a channel that is included in a mutually exclusive set, in this case, we've been turning on a few relays, the physical relay will come on. The channel stays on even after the button that activated it is released. Theoretically, a channel in a mutually exclusive set cannot be turned off without activating another channel in the same set. However, in Netlinks, you can bypass this rule by using another channel manipulation keyword. We've already learned about on, off, pulse, to, and min2. When dealing with channels in mutually exclusive sets, there's another. It's called total _ off. Total off turns a channel or variable off. Unlike off, total off turns off the status of a channel that's in a mutually exclusive set.